using the factor of difference of two squares. Before we start, let us recall the numbers from 1 to 100 that has a perfect square. So it was listed here. We have 1 is equals to 1 squared, or we can write this as 1 times 1. Next, we have 4. If written into an exponential form, it's 2 squared. This would be equals to 2 times 2. And for 9 is equals to 3 squared. We can write this as 3 times 3. And then for 16, we have 4 squared. This is 4 times 4. And then 25 is equals to 5 squared. We can write this as 5 times 5. And for 36, we have 6 squared. We can write this as 6 times 6. And we have 49 is equals to 7 squared. We write this as 7 as times 7. And then we have 8 squared. So 8 times 8. And then for 81 is equals to 9 squared. We have 9 times 9. And for the last one, the perfect square, 100 is equals to 10 squared, or we can write this as 10 times 10. Now, why do we need to know the numbers that have a perfect square? Because this number will help us on how to factor a polynomials using the difference of two squares. So, to be able for us to factor a difference of two squares, write the product of the sum and the difference of the two quantities being squared. So, if the equation is written as this one, a squared minus b squared, we can factor this equation by these two factored form. We have a plus b and a minus b, or we can write this as a minus b and a plus b. So, the order doesn't matter. It's okay if you can write a plus b on the first and a minus b on the second. Okay, so we can easily factor a polynomial using this formula and this pattern. But before we can know what kind of factoring method we can use, since we have already discussed last time the common monomial factor, we must identify this following to be able for us to identify what factoring method we can use to factor a polynomial. So, for step 1, the given term must has two terms. So, for example, we have x squared minus y squared. So, we have here first term and the second term. So, in the step 1, the terms or the given terms must be two terms. Okay, next, we need to identify next is, does our example x squared minus y squared has a perfect square in the first term? So, is x squared a perfect square? Yes. So, our first term is a perfect square. Next, for step 3, we must look again to the number of terms given. The second term must also be a perfect square. Is y squared a perfect square? Yes, it is a perfect square. So, let us write here, second term is a perfect square. And for the last one, which is the step 4, the operation as must be in subtraction. So, the operation must be in subtraction. Okay, so following this pattern, we can easily identify if the given polynomials can be factored using the difference of two squares. Let us try to solve our 5 examples on the board. Okay, so for our number 1 example, we only have x squared minus y squared. So, x squared minus y squared. Following our pattern, we are just going to write these two, and then we distribute now x to the 2. Okay, and then we put the add and subtract sign, so add and subtract sign, and then again we distribute now y, since y is squared, so y and y. So the factored form of x squared minus y squared using the difference of two squares are x plus y and x minus y. Okay, how about for our example number 2, we have x squared minus 16. So first again, the first step, the term given must have two terms. So again, we have 1 and 2. So this is check. For the step 2, the first term must be a perfect square. So x squared a perfect square? Yes. So it is again check. Next, the second term is a perfect square. So is 16 a perfect square? Yes. So why? We can write this 16 into an exponential form powered by 2. So it can be written as x squared minus 4 squared. Now, do the given terms has two perfect squares? First and second terms are perfect square? Yes, it is already a perfect square. So for step 4, is the operation as subtraction? Yes, it is subtraction. Now we can use the factoring of difference of two squares by this example. So again, we distribute now x into the 2. Okay. Next again, we can use positive and negative. Positive, negative. And then we distribute now our 4. So 4 here and 4 here. So the factored form of x squared minus 16 is equals now or equivalent to x plus 4, x minus 4. Easy? Yes, very easy. Now let's try to solve our example number 3. X squared minus 25. So following the steps, we can write or we can factor this. We write first x squared minus 25 into x squared minus 5 squared. Then distribute now x here and x, and then add, subtract 5 and 5. So the factored form of x squared minus 25 is x plus 5 and x minus 5. Okay, for our example number 4, we have 4x squared minus 36. So as you can see, there are already a number in the first term. But can we identify if 4x squared a perfect square? Yes, it is a perfect square. Also with 36. 36 is also a perfect square because if we are going to write this into an exponential form powered by 2, the answer is 6 squared. So we can write this one as 4x squared minus 6 squared. Now, the two terms has a perfect square. We are just going to distribute the equations so that we can find the factored form. So for 4x squared, we have here 2x and then 2x. Again, following add, subtract. So let us try to start first with subtraction and then addition. And then we distribute now our 6 squared. So 6 and 6. So the factored form of 4x squared minus 6 is equals to 2x minus 6 and 2x plus 6. Okay. Our example number 5. 16x squared minus 9. Okay, so I will not show you the solution here in 16 squared x squared minus 9, but instead, you try to solve 16x squared minus 9. Then, if you got the correct answer, I can tell that you already understood our topic for today. So, please get the answer and give it to me after our lesson. Thank you, class. God bless you. Bye-bye.